Top 25 Python developer interview questions and answers. Python developer interviews often focus on coding proficiency, debugging ability, and knowledge of frameworks. Preparing well helps you demonstrate technical skills, problem-solving abilities, and industry practices. Below are 25 key questions with detailed answers. 1. What is Python and why is it popular? Python is a high-level, interpreted programming language known for its simplicity and readability. It supports multiple paradigms, including procedural, object-oriented, and functional programming. Its vast libraries, frameworks, and community support make it ideal for web development, data science, and automation. Python's dynamic typing, platform independence, and rapid development capabilities contribute to its popularity. Additionally, it is widely used in emerging fields like AI, ML, and data analysis, providing developers with versatile tools to solve diverse problems efficiently and effectively. 2. Explain Python's key features. Python is simple, interpreted, dynamically typed, and platform independent. It supports object-oriented, functional, and procedural programming styles. It has extensive libraries that simplify development. Memory management is automatic with garbage collection. Python emphasizes readability, using indentation instead of braces. It's highly extensible and embeddable in other languages. Python supports robust frameworks like Django and Flask for web development. It's widely adopted in data science, AI, and machine learning due to packages like NumPy, Pandas, TensorFlow, and scikit-learn. These features ensure productivity and flexibility. 3. What are Python's data types? Python offers several built-in data types, categorized into numeric, sequence, mapping, set, and Boolean types. Numeric includes integers, floats, and complex numbers. Sequence types include strings, lists, and tuples. Dictionaries represent mapping types, while sets and frozen sets store unique elements. Boolean values represent truth values. Python also supports none type for null values. These data types are flexible and powerful, forming the foundation for handling variables, collections, and logic within Python programs. Developers can also create custom data types using classes. For what are Python lists and tuples? Lists and tuples are sequence data types in Python. Lists are mutable, meaning their elements can be changed, added, or removed after creation. Tuples are immutable, meaning their content remains constant once defined. Lists are created using square brackets, while tuples use parentheses. Tuples are generally faster and memory efficient compared to lists. Lists are better for dynamic data handling, while tuples are useful when data integrity is required. Both are widely used for storing ordered collections of elements. 5. What are Python dictionaries? Dictionaries are Python's built-in mapping type, storing data in key value pairs. Keys must be unique and immutable, such as strings, numbers, or tuples. Values can be of any data type. Dictionaries are mutable, allowing modification, addition, and deletion of items. They are optimized for fast lookups, insertions, and deletions. Common operations include accessing values with keys, iterating through items, and using methods like get, items, and update. Dictionaries are widely used for structured data storage and retrieval. 6. Explain Python's memory management. Python uses automatic memory management, handled by its built-in garbage collector. Objects and data are allocated memory when created and deallocated once no longer referenced. Python manages memory through reference counting and cyclic garbage collection to reclaim and use objects. Developers can manually trigger garbage collection using the GC module. Memory allocation is efficient due to Python's private heap space. This ensures developers focus on coding rather than manual memory management, improving productivity, reliability, and overall program stability. 7. What are Python decorators? Decorators are functions in Python that modify or enhance the behavior of other functions or classes without permanently changing their source code. They use the @decorator_name syntax above function definitions. Decorators are commonly used for logging, authentication, caching, and input validation. They work by taking a function as input and returning a modified version of it. Python's functools module provides built-in decorators like @wraps and @row_cache. Decorators promote clean, reusable, and maintainable code by separating cross-cutting concerns. 8. What is PEP8 and why is it important? PEP8 is Python's style guide, providing conventions for writing clean and consistent code. It covers naming conventions, indentation, line length, imports, whitespace, and more. Following PEP8 improves readability, collaboration, and maintainability in projects. It ensures code adheres to community standards, reducing misunderstandings. Tools like Flake8 and Pylon help enforce PEP8 compliance automatically. Adopting PEP8 practices makes code bases scalable, professional, and easier for teams to manage, ultimately increasing productivity and reducing technical debt significantly. 9. What are Python generators? Generators are special functions that produce values one at a time using the yield keyword. Unlike normal functions, they don't return all results at once, but pause execution between yields. This allows efficient memory usage, especially for large data sets. Generators support iteration, making them compatible with loops and comprehensions. They enable lazy evaluation, improving performance by computing values only when required. Generators are commonly used in data streaming, large file handling, and iterative data processing tasks effectively. 10. What are Python's iterators and iterables? Iterables are objects capable of returning an iterator, like lists, strings, and tuples. Iterators are objects implementing the underscore, iter, underscore, and underscore next, methods. Iterators return elements one at a time, raising stop iteration when finished. The iter function generates an iterator from an iterable, while next retrieves elements sequentially. Iterators support memory-efficient looping, especially with large datasets. Iterables provide flexible containers for data, while iterators handle sequential access. Together, they form the foundation of Python's iteration protocols and loop functionality. 11. Explain Python's exception handling. Python handles exceptions using try-except blocks. Code likely to cause errors is placed in try, while exceptions are caught in except. Additional blocks like else, and finally provide added control. Else executes if no exception occurs, and finally always executes. Custom exceptions can be created by inheriting from the exception class. Exception handling ensures smooth execution, preventing abrupt program termination. It's vital for debugging user-friendly messages and resilience in production applications, making code safer and more reliable overall. 12. What are Python modules and packages? Modules are files containing Python code, functions, or classes, typically with a.py extension. Packages are collections of related modules organized in directories containing an init__.py file. Both promote modular programming by enabling code reusability, organization, and maintenance. Python provides built-in modules like OS, sys, and math. Developers can also create custom modules or install third-party packages via pip. This modular approach ensures scalable projects, fosters collaboration, and reduces redundancy, making applications easier to maintain and extend. 13. What are Python's built-in data structures? Python provides powerful built-in data structures, including lists, tuples, dictionaries, and sets. Lists are mutable, ordered collections. Tuples are immutable and ordered. Dictionaries are key value pairs offering fast access. Sets are unordered collections of unique elements, useful for eliminating duplicates. These structures simplify data storage, manipulation, and retrieval. They also serve as building blocks for more complex structures. Their versatility makes them essential in nearly all Python applications, from algorithms to real-world software development tasks across industries. 14. Explain Python's object-oriented programming. Python supports object-oriented programming, OOP, allowing developers to create classes and objects to model real-world entities. OOP principles include encapsulation, inheritance, polymorphism, and abstraction. Classes define attributes and behaviors, while objects represent instances. Inheritance promotes code reuse. Polymorphism allows method overriding, and encapsulation safeguards data. Python's OOP enhances modularity, scalability, and maintainability. Frameworks like Django utilize OOP extensively. OOP is a vital paradigm for building complex systems, making Python a powerful tool for structured and reusable application development. 15. What is Python's GIL? The Global Interpreter Lock GIL is a mutex in C Python that allows only one thread to execute Python bytecode at a time. It simplifies memory management, but limits true multithreading performance. The GIL is less impactful for I/O-bound tasks, since threads can release it during waiting. For CPU-bound tasks, multiprocessing is often preferred. Alternatives like Jython or IronPython don't have a GIL. Developers optimize performance using multiprocessing, async programming, or external libraries written in C to bypass limitations. 16. What is Python's with statement? The with statement simplifies resource management by automatically handling setup and teardown operations. It ensures proper release of resources like files or network connections, even if exceptions occur. The statement uses context managers defined by __enter__, and __exit___ methods. For example, with open file.txt as f ensures the file closes automatically. This approach promotes cleaner, safer, and more readable code. Developers often use within file operations, threading locks, or database connections to ensure reliable resource handling. 17. What are Python's Lambda functions? Lambda functions are anonymous, one-line functions defined using the lambda keyword. They take any number of arguments but have a single expression. These functions are often used for short, throwaway operations like sorting or filtering data. Unlike normal functions, lambdas don't require a def statement or naming. They are commonly used with functions like map, filter, and reduce. Lambdas improve code conciseness and readability, especially in functional programming contexts or when defining quick, temporary logic blocks. 18. What is the difference between shallow copy and deep copy? A shallow copy creates a new object but references elements of the original object. Changes to mutable elements affect both. Deep copy creates a fully independent object, duplicating all nested elements. Python's copy module provides both copy for shallow copies and deep copy for deep copies. Shallow copies are faster but less isolated, while deep copies ensure complete separation. Understanding these differences is crucial for avoiding unintended side effects, especially when working with complex, nested data structures in applications. 19. Explain Python's __init__ method. The __init__ method in Python is a constructor automatically called when creating an object from a class. It initializes instance attributes, ensuring objects start with defined values. For example, def__init__ self name self.name equals name. This method improves clarity by setting up necessary variables immediately upon object creation. Although it's not mandatory, using __init__ enhances code organization and object reliability. It's a core concept of object-oriented programming in Python, supporting structured and reusable design patterns effectively. 20. What are Python's popular frameworks? Python offers frameworks across multiple domains. For web development, Django and Flask are widely used. For data science, TensorFlow, PyTorch, and scikit-learn are popular. Automation often uses Selenium and PyAuto GUI. For GUI development, frameworks like Tkinter and PyQt are common. FastAPI is gaining traction for building modern APIs. These frameworks provide pre-built modules, tools, and features that accelerate development, reduce boilerplate, and ensure best practices. Choosing the right framework depends on project requirements, scalability needs, and developer familiarity. 21. What are Python's built-in functions? Python provides numerous built-in functions for common tasks. Examples include len, type, print, range, sorted, input, and sum. These functions simplify code, enhance readability, and improve efficiency by reducing the need for manual implementations. Built-ins cover type conversions, mathematical operations, string handling, iteration, and more. Python also allows extending functionality with custom functions. Understanding built-ins improves coding speed and problem-solving, enabling developers to write concise, effective, and maintainable code across a wide range of applications. 22. Explain Python's virtual environments. Virtual environments isolate project dependencies, ensuring packages don't conflict between projects. Developers create them using venv or third-party tools like virtualenv. Each environment maintains its own Python interpreter and libraries. This allows specific versions of packages to be installed without affecting global settings. Virtual environments are crucial for collaborative projects, deployment, and maintaining reproducibility. Activating and managing them is straightforward. By using virtual environments, developers maintain cleaner systems, reduce dependency issues, and guarantee stability across multiple projects efficiently. 23. What is Python's __str__ method? The __str__ method defines how an object is represented as a string when printed or converted with str. By customizing this method, developers make objects more readable and user-friendly. For example, def__str__ self-return f name, self at name. Without it, objects display less informative memory addresses. This enhances debugging, logging, and user output. __str__ differs from __repr__, which is aimed at developers and debugging. Together, these methods provide clear, descriptive string representations of Python objects. 24. What are Python's list comprehensions? List comprehensions provide a concise way to create lists using a single line of code. The syntax includes an expression, loop, and optional condition. For example, x** for x in range 5 generates squares. They improve readability, reduce boilerplate, and execute faster than traditional loops. List comprehensions also support nested iterations. Beyond lists, similar syntax applies to sets and dictionaries. This powerful feature simplifies tasks like filtering, mapping, and transforming collections, making Python code elegant, efficient, and highly expressive. 25. What are Python's best practices for coding? Best practices include following PEP 8 for style, writing modular code, and using meaningful variable names. Developers should handle exceptions, use version control, and apply testing frameworks like PyTest. Documentation is vital for maintainability. Using virtual environments prevents dependency issues. Code should be optimized for readability, not just performance. Leveraging built-in functions and libraries avoids reinventing the wheel. Following these practices ensures professional quality code, improves collaboration, and enhances software scalability, reducing technical debt and increasing long-term project success. Python requires understanding core concepts, libraries, and frameworks. By preparing answers to these interview questions, you demonstrate problem-solving, coding proficiency, and adaptability. Strong fundamentals secure success in technical interviews.